We're going to go through now very quickly, this time in VoiceThread, so you can make your comments on this and think about the mathematics of this stuff. We're going to go through just a simple pond and a meadow. So if you remember, I've already started this catchment. I edited it. I've already made it an area. I haven't. I'm making it an area of 1 acre. And the curve number you can look up here, and you're going to see we're going to generally use type B soils, though the ones around rapids can be type A, in other words, sandy. But when you start looking at all these descriptions of land, you're going to develop a few of these you're going to use a lot, and 58 is our meadow. Again, a lot of municipalities won't let you use more than 58 for a pre-development condition. You could have selected it. Time of concentration, again, you need to know a couple things. We'll go through that later. But we want to start learning normal range of velocities. You already know raindrop falls at 10 meters per second. Dan will tell you that. 3 to 10 for normal range of velocities in a channel, and then it gets slower as you come back from where the rain hits the ground, in the order of 0.1 or less feet per second to 1 feet per second in shallow concentrated flow, and on. So, but we can also very quickly sometimes just go on and go put in direct entry. I'm going to put in again 5 minutes, though 5 minutes if you're flowing through asphalt gets a big area. 5 minutes on a meadow is not very far away. Alright, so I'm going to hit these here, okay. We have to remember that we have to go, before we start, we go to General Soil Conservation Service, TR20, rainfall. We've been working with a 100-year storm, so I'm going to do that. 100-YR. I'm going to save it and hit OK or apply. Okay, which means now when I hit right click and load report, I get 3 CFS. So if you compare that to what it would have been a parking lot, that would have been 9 CFS. So 1/3 of the peak. Now the runoff will also be different as well. So I'm going to close that up. Once you get your rainfall figured out, the big thing we're going to talk about here is how to do a pond. We're going to do it quickly. We're going to edit the pond, and we're going to always use detention pond, even if we're doing catch basins. So detention pond, you're going to do with the storage, and you go from the bottom up. And so I'm going to put the invert here. These are your different ones. We're going to almost always use custom stage data, so that's what I'm going to do here. Elevation of 100. And I'm going to typically have you put your ponds in square feet and your basins in an acre. In other words, your drainage basins. So I'm going to think about something that's 100 by 100 square feet. So that's 10,000. 100 by 100, you should know from a hectare, is 10,000 square feet. I'm sorry, elevation of 100 and 10,000 square feet. Now I'm going to go up at 1:1 for 10 feet. 110. Now think about it. What is that surface area? Well, 1:1 for 10 foot means it's going from 100 a side to 120 a side. 100 a side to 120 a side if you go 1:1 at 10 feet going up. And so that is going to be 120 by 120, or 4,400. And that's all I'm going to put in here. Very often you've got one for every contour, but I want you to visualize that 1:1, 2:1, 3:1, because it is a way to go about doing calculations of areas. I'm going to go ahead and hit OK. And I also need to always put an outlet here. So my outlet in this case is going to be, I'm going to put usually one at the bottom, one at the top, but in this case it's just going to be a broad crested weir at an elevation of 108, and a crest length of, I don't know, 120 feet on one side. The breadth is how thick across the top, and you'll see that'll do some calculations. I'm going to hit pause here for a second. Alright, so we have defined this pond by using a detention pond, by giving it storage, which we put in square feet. We don't use large units. That'll be something people tend to mess up. And we're going to almost always do it by something that's not prismatic. We're going to use irregular area. But that sense, we put something in here that was basically 100 elevation at the bottom, 100 by 100 at the side at the bottom, and a 1-to-1. That's what it would become. Draw that out, think about it. You should be able to do some quick calcs that way. Again, from the concepts we were going to be introduced in estimating, but then use a lot in other classes. Hit an OK here. Your outlets. Right now I put an outlet down at the bottom. The outlets generally, you're going to right click and insert a blank row. You should go bottom to top. I'm going to put an outlet at 102. I'm going to make this a culvert. Out at elevation, in other words, that's where it's leaving the pond, 102. I'm going to run it for 100, for 2 feet of length. I'm sorry, 100 feet of length. At 2 feet is 2%, and a Manning's number again, 0.013, is pretty much the one we're going to use. Entrance, you can all of a sudden do all kinds of different ones. Click through. The bigger the number, the more the energy loss. So I've got a large energy loss there. Once again, I hit OK. Diameter camp, I'm going to put a very small diameter, 2-inch diameter, area of pi square inches. Or you know how to do those calculations. Right click, reroute to there. And now as I hit right click, node report, you see that hardly any water left, and it went up to 100.57, which makes sense. 1 acre of meadow does not generate a lot of rainfall, a lot of runoff, so I'm going to close that up now and go back and just change it now a little bit higher. Edit that. Let me go up by an area, an order of magnitude, up to 10 acres, and we'll talk about then how you estimate the size in the voice thread. So how do you estimate the size of a pond before you start? I think the best way to do it is to think about what's the total amount of rainfall to go inside of that. That's going to need to be contained if there was no outlet. There's a couple of ponds, that's the dead end ponds. You always want to think about these dead end ponds and make the biggest you're going to make a pond is the volume of the total runoff in the catchment basin. So I'm going to hit OK here, right click, and now node report. You see there, still it's only gone up to 105. Why? Because of the volume of the volume of runoff is going to equal to a percentage of the rainfall now because it's a meadow. And we can come back here and just once again prove that. We can right click, edit that, and now change its area to the curve number of 98. Hit OK, right click, node report, and now you have errors because of the fact that it peaked out over. And you can see the difference in the hydrographs here. Right, you can see the difference in the this is the rainfall hydrograph, the runoff hydrograph. You're filling the pond between these two curves. The area between the inflow and the outflow hydrograph is the volume of storage, and you see the peak elevation is 108.44, so it still hasn't gone up over the top. All right, that's about 10 minutes. I'm just seeing how VoiceThread takes on this. Once again, to review, we have to definitely do our calculation information, put our storms in there, SCS type 2, 6 inches for a 100-year storm, 4.8 for a 25-year storm, 4.2 for a 10-year storm, and then down the pike. You put your areas of your subcatchments or basins in square feet, in acres. You put the area of the pond in terms of the surface area of the pond in square feet. You need to define each basin by a curve number and a time of concentration and an area, and each pond is defined by a set of contours and then a set of outlets. And the outlets can include even infiltration out of the pond or exfiltration, but it gets a little complicated. We'll talk about how you do that and what are the velocities of water through soil.